Our story begins with a bang, quite literally, the Big Bang. Picture, if you will, a universe condensed into a point smaller than an atom, then in an instant, an explosion of unimaginable power, the birth of space and time itself. The universe, incredibly hot and dense, began to expand and cool. In those first, fleeting moments, only energy existed. As the universe expanded and cooled, this energy began to condense into matter. The first atoms to form were the simplest and lightest, hydrogen and helium. These two elements, forged in the crucible of the Big Bang, would become the building blocks of everything we see in the cosmos today. The early universe was not a place of order and structure. Instead, it was a chaotic sea of hydrogen and helium gas expanding outward in all directions. Yet within this chaos, the seeds of galaxies, including our own Milky Way, were sown. Gravity, the architect of the cosmos, began to exert its influence, drawing these primordial elements together. Imagine the vastness of space filled with a thin mist of hydrogen and helium. Gravity, relentless and patient, began to pull these atoms together. Over millions of years, these atoms clumped together, forming enormous clouds of gas. These clouds, some stretching for hundreds of thousands of light years, were the progenitors of galaxies. Within these giant gas clouds, gravity continued its work, pulling the gas inwards. As the gas collapsed, it spun faster and faster, like a spinning figure skater pulling their arms in. This spinning motion caused the clouds to flatten into giant disks, resembling cosmic frisbees. These swirling disks of gas were not uniform, they were lumpy, with some regions denser than others. These dense regions, pockets of concentrated gas, would eventually become the birthplaces of stars. The stage was set for the next act in the Milky Way's epic story, the birth of stars. Within the swirling chaos of those early gas clouds, gravity continued to draw matter together. These denser regions, enriched with the primordial hydrogen and helium, collapsed further under their own weight, forming massive structures known as protogalaxies. These protogalaxies were the seeds of future galaxies, including our own Milky Way. They were smaller and less organized than the majestic spiral galaxies we observe today, but they contained the raw materials and the gravitational engine needed to evolve. As these protogalaxies continued to accrete gas from their surroundings, they grew in mass and gravitational influence. The process of star formation, initially sporadic and localized, began to accelerate, igniting the darkness with the light of newly born stars. The Milky Way, still in its infancy, was beginning to take shape. Deep within those swirling clouds of gas and dust, a cosmic ballet was unfolding. Gravity, the choreographer of this dance, drew the gas and dust together, pulling it into tighter and tighter clumps. As these clumps contracted, they spun faster and faster, generating heat and pressure at their cores. These dense, hot cores, known as protostars, were the precursors to stars. When the temperature and pressure at the heart of a protostar reached a critical threshold, a spectacular transformation occurred. Nuclear fusion ignited. Hydrogen atoms, forced together under immense pressure, fused to form helium, releasing a tremendous amount of energy in the process. This energy, radiating outward from the core, balanced the inward pull of gravity, stabilizing the newly born star. Thus, a star was born, adding its light to the nascent Milky Way. Section 5, Starry Generations, Population 1 and the Second. The first stars to illuminate the Milky Way were very different from our Sun. These stars, known as Population 2 stars, formed from the primordial hydrogen and helium that filled the early universe. They were massive, hot and short-lived, exhausting their nuclear fuel in a cosmic blink of an eye. As these early stars burned through their fuel, they produced heavier elements in their cores, elements like carbon, oxygen and iron. These elements, forged in the nuclear furnaces of stars, were scattered back into space when these stars exploded as supernovae. This enriched material, seeded with the building blocks of planets and life, became incorporated into later generations of stars known as Population 1 stars. Our Sun, a relatively young Population 1 star, formed from this enriched material, inheriting the legacy of countless stars that came before it. Section 6. Shaping a Galaxy, the Milky Way's Structure. Over billions of years, the Milky Way, sculpted by gravity and enriched by generations of stars, evolved into the majestic spiral galaxy we observe today. Our galaxy, a vast city of stars, gas and dust, is characterized by its distinctive structure: a central bulge, a flat disk with spiral arms, and a surrounding halo. The central bulge, located at the heart of the Milky Way, is a densely packed region dominated by older reddish stars. This bulge, thought to harbor a supermassive black hole at its center, acts as the gravitational anchor of our galaxy. Extending outward from the central bulge is the galactic disk, a thin, rotating plane containing our Sun and billions of other stars. Within this disk, spiral arms, regions of active star formation, trace out a pattern of cosmic beauty. Surrounding the disk and the bulge is the galactic halo, a spherical region containing globular clusters, ancient remnants of the Milky Way's formation. This halo, composed of sparsely distributed stars and dark matter, represents the outermost reaches of our galaxy's gravitational influence. Section 7. Galactic cannibalism, a cosmic feast. The Milky Way's evolution was not a solitary affair. Throughout its long history, our galaxy has engaged in a cosmic ballet of mergers and acquisitions, consuming smaller galaxies and incorporating their stars, gas and dust into its own. This process, known as galactic cannibalism, is a testament to the power of gravity and the hierarchical nature of galaxy formation. As the Milky Way grew in mass and gravitational influence, it attracted and devoured smaller galaxies that ventured too close. Evidence of this galactic cannibalism can be seen in the remnants of these consumed galaxies, such as stellar streams, arcs of stars ripped from their parent galaxies and stretched out by the Milky Way's gravity. These streams, like cosmic breadcrumbs, tell a tale of past mergers and the Milky Way's insatiable appetite for growth. Section 8. A fateful encounter. The Milky Way and Andromeda collide. The Milky Way, despite its long history, is not destined to exist in isolation forever. Our galaxy, along with its smaller companion, the Andromeda Galaxy, are hurtling towards each other on a collision course, destined to merge in a spectacular cosmic display. This encounter, predicted to occur in about 4.5 billion years, will be a transformative event for both galaxies. As these two spiral giants approach each other, their gravitational fields will intertwine, distorting their shapes and triggering intense bursts of star formation. The galaxies will pass through each other multiple times, their stars and gas clouds interacting in a complex gravitational dance. Eventually, they will coalesce into a single, larger elliptical galaxy, a cosmic blend of the Milky Way and Andromeda. Section 9. The fading light, the Milky Way's final act. As the Milky Way ages, its star formation rate will gradually decline. The gas and dust that fuel the birth of stars are finite resources, and over time, they will become depleted. Eventually, the Milky Way will exhaust its supply of star-forming material, and its era of active starbirth will come to an end. The galaxy will then be dominated by aging stars, their light gradually fading as they exhaust their nuclear fuel. The once vibrant spiral arms will become less distinct, and the Milky Way will transition into a more quiescent state, its light dimming as it enters its twilight years. The future of the Milky Way is a reminder of the cyclical nature of the cosmos. Galaxies are born, evolve, and eventually fade away, their legacies imprinted on the fabric of space-time. The Milky Way, our cosmic home, will eventually meet its end, but not before leaving behind a legacy of stars, planets, and perhaps even life beyond our imagination.